On the introductory slide here, and one of the reasons is because I have broken this down into two different parts. In our first part, we're going to focus on the fishes that are some of the earlier fishes like the sharks and rays, and then we're going to move into the bony fishes and eventually what we call the tetrapods. There are approximately 50,000 species of marine vertebrates. So when you think about that in terms of the number of invertebrates, there are far more invertebrate species than there are marine species. And I mean, than there are vertebrate species. And of those 50,000 marine vertebrates, about 30,000 of those are fishes. So while most people are fascinated with things like the whales and the dolphins, seals, things like that that are in the ocean, they are a very, very small percentage of the overall makeup of the species that are in our oceans. And of those 30,000 species of fish, 60% of them only live in the ocean. Okay, so we have more saltwater fishes than we have freshwater fishes. There are some fish that can live in salt and freshwater. We'll talk about what those are called. Okay, so you can see here a little bit of an evolutionary tree. The fish started their evolutionary path about 500 million years ago. And this was about 50 million years after that Cambrian explosion. So remember, the Cambrian explosion was when the invertebrates really took root on the continent. And it took another 50 million years for even the most simple fish to come about. And in fact, at about 40 million years, which is here, which is called the Devonian period, this time, the Devonian, is what they call the age of the fishes, because this was when the fish really came into existence. Because prior to that point, there were some fish, but they became extinct. So during this Devonian period, this is when the current fish population that we see now came into existence. Notice that all of these organisms, not only the sea dwellers, but the land dwelling vertebrates, all came from a common ancestor that started in the oceans. Okay, so all vertebrates started in the ocean. You'll see the fishes here are on the left, and what we call the tetrapods are on the right. This would be your four-legged creatures. And they all develop from this common ancestor. And then you'll notice that the land-dwelling tetrapods all developed from what we call the bony fishes. So we'll talk about those bony fishes as well. The dinosaurs didn't actually appear until much, much later, and they became extinct. So they were a very late addition to the tetrapods. Now, in terms of dates here, you don't really need to worry about the dates. Just recognize that the fish came about later than the invertebrates and that they all had a common ancestor. Okay, so the main groups of fishes, two of them are now extinct, but they did initially come to be, and they were called the spiny sharks and the placoderms. Placo means plated, so these placoderms had like a plated covering to their bodies. And there is actually a current fish that has a little bit of plating on it, which we'll talk about. The three, what we call extant, extant means in current existence. So it's the opposite of extinct. These three groups, and these are the ones we're going to focus on, are called the jawless fish, the cartilaginous fish, which means they have cartilage, and the ray-finned fishes, also called the bony fishes. Get rid of this bar here at the bottom. There's another little guy down here that is actually part of our bony fishes, and they are called the lobed fin fishes. So we'll talk about them separately, but they are actually part of our bony fish group. So all of these organisms that we're talking about now are under the same phylum. Okay, so they're kingdom Animalia. They're all animals. They are all part of the phylum Chordata, meaning they have a spinal cord. But this phylum Chordata is very, very diverse. Remember, some of our invertebrates, like the acorn worm and the tunicate, were considered chordates. Okay, so there is a subphylum called Vertebrata, which is what all of these organisms are in. So everything we talk about from here on out is part of the subphylum Vertebrata. But again, even that subphylum is so diverse. So we're going to break these down to the next level, which is class. So we have kingdom Animalia, phylum Chordata, subphylum Vertebrata, of which we are part of that subphylum. And now we're going to talk about the jawless fish, which are part of the class Agnatha. So when you hear Agnatha, you think jawless fishes. These are the most primitive of the fishes in existence, and you can see they look very primitive. And the reason they're called jawless is because they do not have a movable jaw. So they don't have the two sets of jaws that can move. They just have a single mouth part. And there's actually only two different types of organisms in this group, or this class rather. And one of those is called the lamprey, or lamprey, some people say. And the other is called a hagfish. So these are very interesting fish, but extremely ugly. So basically, they are eel-like fish, both of them. I'll show you the hagfish in a minute. They don't have any jaws, and they don't have your typical paired fins that you see in most fish. So for example, here's a bony fish down here, and you can see that the fins come in pairs. We'll talk about these fish later. The lamprey and the hagfish, they have a single fin down their back, and it allows them to swim with an eel-like motion. They also don't have bones. They have a cartilage skeleton. Okay, so think of like the cartilage in your knee or your nose, and that is what their skeletons are made of. So if you look at the mouth of this lamprey in the slide, you will see what looks like a bunch of teeth, and that is in fact what they are. Essentially, the way the lamprey feed and the hagfish also feed in a similar way is they will suction their mouth part onto an organism, like we have a lamprey attached to a fish over on this side, and they essentially rotate their mouth until those teeth grind in and hold onto the organism. So they are basically parasites. Parasites feed from their host and they live on their host and they benefit from that organism. So the lamprey will basically suck the blood out of whatever organism it is attached to, kind of like a leech would do. Now, if a lamprey stays on the same organism long enough, it will eventually kill its host. But the goal of a parasite is not to kill the host, because then they don't have any way to live. So they generally just weaken the host. You will oftentimes see pictures of sharks swimming with these lampreys attached to them. So that's what you'll see along them. They also are beneficial in some ways because they can scrape along the skin surface and remove parasites and other things from the outside of the fish. Now, if you're at all familiar with fish like salmon, which I think this is a salmon in this picture, lamprey are similar in their reproduction. What that means is they will actually spawn, meaning they will mate and have their young in fresh water. So they need to swim up rivers to have their babies, and then they will return to the oceans. The lamprey became most well known because in the 1940s and 50s, they actually invaded the Great Lakes. So the Great Lakes, even though they are freshwater, the lamprey left the oceans, they swam upriver, and they have now populated the Great Lakes. And they have greatly, actually, I think this is a lake trout. They have greatly depleted the lake trout and whitefish in the Great Lakes. It is still a problem today because they can be very harmful. All right, so of course we have to have a video of these guys.
Okay, right in the top.
Paddlefish in this stretch of the river are heavily parasitized by silver lampreys, and so almost every fish every paddlefish we see has numerous fresh wounds, scars, and actual lampreys attached. I think our record is 11 or 12 on one fish.
As young, lamprey are blind and toothless. They bury themselves into the sand. And there, at the river bottom, they lay in wait for up to 7 years. When they come out, they're a changed fish. Their gill holes are fully formed. They can see, and they've grown a mean set of teeth, rings of them. They even have teeth on their tongues. so they can rasp into the flesh of their prey and suck blood. Once attached to a paddlefish, they suck out as much as they can. They rarely, if ever, kill the fish, but they leave terrible scars. These beady-eyed bloodsuckers attach to bodies, snouts, even up into gills.
These are lamprey scars. You can even see the teeth marks on them.
Okay, I'm going to stop that there. So this particular video shows a river dweller, what's called a paddlefish. But as I mentioned, they can be found essentially in fresh and salt water, mostly salt water.
Okay, right in the tub.
Okay, the second of the jawless fishes look very similar to the lamprey, and they are called the hagfish. Again, they don't have actual vertebrae, they are cartilaginous. But the lamprey do have some protection around their spinal cord, what would be considered vertebrae. These guys have a naked spinal cord, which is called a notochord. There's no bony protections around it whatsoever. Once again, they have no jaws. Their mouth is kind of similar to that of a lamprey. But rather than being parasitic on living fish, the lamprey or the hagfish prey on dead and dying fish. So you will find these scavenging for the remains of dead organisms. And they do live on the bottoms, often at great depths. They're really, really slimy creatures, and they've actually developed a way to clean the slime off themselves. They'll essentially tie themselves into a knot and then shove the knot down their body until it strips off that extra slime. They can be found at depths greater than 1,500 meters, which makes sense because when organisms die, they'll sink to the bottom, and that bottom area is where they feed. Here's a video of these beautiful hagfish feeding on a carcass.
At the bottom of the ocean dwells a bizarre-looking creature. A fish so ancient it has remained unchanged for 300 million years. This is the hagfish. Its velvet-smooth skin lacks scales and slithers along the ocean floor. It has a skull, but no spine. Tiny holes run along the sides of its wriggling body, some for breathing and some for sliming. But its most bizarre feature is its mouth. Like something out of an alien movie. This jawless maw is made for mincing up dead bodies. Multiple rows of sharp teeth are packed on 2 bony plates. With its single nostril, it picks up the sweet scent of death. A feast has arrived. It has no fins, but its paddle-like tail makes light work of swimming. The hagfish latches on and its mouth goes to work. Flesh is ripped from the carcass and shoved down its toothy throat. Soon, it's a frenzy of multiple mincing mouths. And to keep other hungry onlookers at bay, the hagfish excrete copious amounts of slime into the water. A shy shark snatches one, but ends up with a mouthful of snot instead. In minutes, the hagfish will strip the carcass to bone. It may be months before they find another meal like this.
Okay, so while they are disgusting, they are a very important part of the carbon cycle, because remember that as that carbon in the organism decays, it needs to be recycled, and these fish do a good job with that.
At the bottom.
Okay, so now we're going to move on to the cartilaginous fish that you may be more familiar with. And this is another class. So we've talked about the class Agnatha, which was our jawless fish. And now we have the class Chondrichthyes. Chondra means cartilage. You may have heard of chondrocytes before. You may not have, but chondrocytes are the cells that produce cartilage. So the chondrichthyes are your cartilaginous fish. And there are two main groups, what we call the elasmobranchs, which I'm sure you've all seen. These are the sharks and things like the rays and skates. And there is a second lesser known group called the chimeras. Again, these are vertebrates, and they do have a protective vertebrae or a vertebra, but they are made of cartilage as well as the rest of their bones. So while their spinal cord does exist, it is not protected by bony, but cartilaginous vertebrae. All right, so let's talk about these chimera first. They're kind of creepy looking. They are generally found in deep waters, which is why people didn't know a lot about them early on. Generally found at depths of about 300 down to 2,400 meters in depth. So that's very, very deep. They're similar to the sharks and rays, but they are different in a few ways. So first of all, these chimera do not have any scales whatsoever. We'll talk about what shark scales are, but the chimeras have no scales. So in that way, they are similar to the lamprey and the hagfish. They have what we call a single gill slit. So it is essentially just a slit on the side through which they pass oxygen through. This again is different from sharks because sharks have multiples. And their fin, tail fin, also looks very different from sharks. It is pointed rather than that typical circle shape that we know. They're also generally found in colder waters, so you're not going to find these in the tropics. They're going to be in your cold, deep waters. All right, that's all we're going to talk about with the chimera. You'll probably never see one of these again. Okay, so now for the elasmobranchs. These are the common cartilaginous fishes like your skates, rays, and sharks. The skates and rays are just essentially flattened sharks. So rather than having like fins on their backs and on their stomach sides, they have their fins on their sides. So they're flattened and their fins almost act like wings. So they flap rather than squiggle, I guess you could say. So the manta ray, which you'll see in the upper right, this is the largest of the rays, and it can actually have a wingspan, they call it, from tip to tip of 7 meters. There's about 3 feet in a meter, so that's 21 feet across. If you ever get a chance to go to Stingray City, which is in the, I forget which island it's at. It's somewhere in the Caribbean. These are incredible. You can get in the water with them and they'll just swim right up to you. Pretty awesome creatures. So the skates and rays are very similar. Sometimes you'll see some differences in their tails. Some of them have a stinger. This long pointy piece is not actually the stinger itself. The stingers occur in these back flaps at the top end of the tail there. So it's not this long piece hanging off that's the stinger. They're actually barbs that can release venom. Skates do not have any venomous barbs, and it's generally the wing shape that differentiates a skate from a ray. And not all rays and skates have stingers. They have different feeding methods. Some of them just eat plankton or are considered herbivores. Others are carnivores. So there's a variety of feeding types. Okay, so the sharks are our other elasmobranchs. And obviously you can see they're more sleek and elongated, not flattened like the rays. They are capable of swimming extremely fast. And of course, the most famous shark is the great white shark because of its occasional attacks on swimmers. And we'll talk about why those attacks actually happen. So we're going to just take, whoops, let me mute that. We're going to just take a quick look at shark anatomy here so you can kind of see that shark swimming there. They have several fins. They have a large fin on their back called the dorsal fin. Dorsal means back. So whenever you talk about the dorsal surface, you are talking about the back side. Just like in people, your pecs refer to like your shoulder region. So they do have 2 pectoral fins, 1 on each side. Those would be around the shoulder area. And then they have what are called pelvic fins. Pelvic down near the pelvic region. Again, just like in human anatomy, the pelvis would be your hip and girdle region. And with the exception of the dorsal fin, the other fins are paired. Okay, and you're going to find this to be pretty common among all the fishes. The dorsal fin is split, but it is still considered a single unpaired fin. Now we're going to learn in the bony fishes that the bony fish have a cover over their gills, but the sharks do not have a gill cover. They have what are called gill slits. They're just essentially flaps in the side of the fish. And the sharks will always have 5 to 7, depending on their species. Sharks actually do have scales. Now, they're not the same as the scales that you see on most fish that you're familiar with, but they're essentially modified teeth. And if you run your hand over the surface of a shark, you would think it would be smooth, but it's not. It's actually rough like sandpaper. So they're essentially lots of tiny little teeth that would feel rough in texture. Now you can't see all of it here because I cut it off with the movie, but you can see it here in this picture. So the tail does have a crescent shape, and this is referred to as the caudal fin. You can't see it here, but it's a C-A-U-D-A-L. We're going to see this when we do our dissections too, so you'll become more familiar with these terms. In the sharks, the tail fin does not have an even distribution. You'll notice that the top part is much longer than the lower part, and that is pretty typical among all sharks. It is called heterocercal. You don't need to know that term, but you should know that hetero means different. So heterocercal just means they're different size lobes. We'll talk about the spiracle a little bit more when we do the dissection. Okay, so of course, sharks are very famous for their teeth. You can often pick them up on beaches. This is a sand tiger shark here. This one is probably from a great white, but you can see that they are serrated, meaning they have little jaggy sides. Some are more serrated than others, and oftentimes the teeth you'll find washed up on shore have been worn down, so you might not see these serrations. But the interesting thing about sharks' teeth is they are found in layers. So you can see that they have a continuous replacement of teeth. They lose them very frequently, and when one falls out, another one just rotates into place from behind. So unlike people, where our teeth come up from the gum to replace a missing tooth, sharks can't ever afford to have teeth missing because it's their livelihood to feed. So they have constant teeth in waiting to replace the missing ones. So fins are built in a certain way to help fish to keep from sinking. Sharks do not have any way of staying afloat other than their fins. Okay, so you will always see sharks swimming. They must constantly swim for 2 reasons. Number one, they have to keep water flowing over their gills because the water is where they pull the oxygen from. And if they stop moving, because their gills are just slits, they will basically suffocate, okay, because they will not have enough oxygen. So these gill slits require that the sharks continually move, even when they're sleeping, in order to pass oxygen over them. And sharks do not have what we call swim bladder. We'll talk about the swim bladder more, but the swim bladder in bony fish is what helps keep the fish float. Sharks also must swim so that they don't sink to the bottom. And the way this happens is their pectoral fins provide lift as well as their caudal fin. So as they swish that fin back and forth, because this top fin is larger, it helps to push the fish up in the water column.